It's finally the time. I'm Kevin Omar Lopez Castellanos, and I'm going to finally show you my last presentation, the vulnerability assessment. As you're all aware of this project, meant to provide a presentation on the person who we are assigned as our partners. We review the servers that they harden, review the servers and protocols that they allowed and what they filtered. There we go. Time to present the findings. So this was all done over the course of the semester, and let's see the result of that hard work. So the classmate I was assigned is Tyler Rowlands, and like the rest of us, he was assigned the two servers, Windows Server 2019 and the Linux Ubuntu Server 20 LTS via the NetLab Plus virtual machine. So what were we particularly assigned? Again, like the rest of us, Tyler Rowlands was assigned to configure two servers done on NetLab Plus, and the configurations and the hardening were all accomplished by Rowlands himself through research that he gathered over the course of the semester on the various applications and protocols that he was assigned to review, research, and learn the configurations and remediations for. Protocols include DNS, SMTPS, HTTPS, and applications, as we all know, Dovecot, Apache 2, PostgreSQL. And in this presentation, we'll be discussing the findings, discuss their criticalities, the recommendations for the remediations of any vulnerabilities that were discovered through this assessment, and the conclusions will be discussed. And for any greater technical detail, you will find it in the vulnerability assessment report provided to the professor. These findings. First, we have to discuss, were any findings discovered? And the answer is yes. I was able to discover a total of 4 independent vulnerabilities. What I mean by independent meaning their own separate vulnerabilities, because one particular vulnerability was repeated. But first, we have to discuss, what were the tools used? It was using Greenbone, again, through the NetLab Plus service. And we were required to use the checklist of required services as our guide for determining whether any unnecessary protocols were still within the server, and if any critical protocols and services that we were required to install were not found in the scan. The goal of the scan was to search for that. And now, as you can see by the table below, this was provided from the assessment report from the scan that I performed on Rowland's system. 4 independent vulnerabilities. 3 of them had a severity of medium level and only 1 with low level. So all in all, we can gather this is a good thing. Very few vulnerabilities were discovered, and none of them were of high criticality. And that should mean that the server was pretty well put together. First, we have to discuss, how were the scores determined? See, Greenbone supports the Common Vulnerability Scoring System, otherwise known as CVSS, and that's important because I use this acronym quite often in the presentation. I did not spend enough time to learn what version of Greenbone I was using, so I decided to make an assumption and use the stats from version 3. So from the version 3 of Greenbone, the scores are determined by multiple metrics, such as base score, which is like the baseline, the standards, the functionality, the operations of the systems. Then there's a temporal score, scores based on properties of the systems that were time dependent. And finally, the environmental score. That means any kind of property or vulnerability that was discovered based on the environment that it was operating in, because oftentimes we tend to ignore what environment are we operating in, as if, like, when we're working at our jobs, are we working in a secure environment using secure networks? We don't know for certain, and that's the job of the IT department to ensure that we have nothing to worry about. And during version 3, the severity of these vulnerabilities are divided into 5 levels. If it's 0, that means there's no severity. If it's between the scores of 0.1 to 3.9, it's considered low. If it's between 4.0 and 6.9, it's medium. And then there's the high criticality, 7.0 to 8.9. And lastly, critical. It's a good thing that only the low and medium criticality level vulnerabilities were discovered, and thus we do not need to go into further detail regarding these severities. Findings. The first finding was the TCP timestamps, and basically they describe when a service was rendered or a command was placed. And the reason why these timestamps are so significant is because they can be indicators that can allow attackers to discover any patterns. Patterns in intervals when patches are installed or when IP addresses are repeated. By understanding the frequency at which certain services are used, we can determine what services are most critical to the operations of a company. So what I know about this finding is that it's the low criticality one. Only has a score of 2.6, so we can pretty much regard this as a very low risk finding, and it was only found in the Linux Ubuntu server. So I would suggest remediation not being super necessary unless you really want to make your systems airtight, secure. I simply recommend that you go to the file /etc/systil.conf and add the line to this file. This net.tpf4.tcp underscore timestamps equals 0. This hides the timestamps from being displayed. And to execute it, you simply enter the command below. The second finding was reporting vulnerable cipher suites. What cipher suites are is that they're the instructions behind enabling the secure network connections that are prevalent in transport layer security, otherwise known as TLS. And they do that through these use of built-in algorithms and protocols. So cipher suites are these security packages. That's what we can refer them to. Security packages that allow us to implement levels of security without having to build everything from scratch. This was a medium level criticality, and this was exclusive to HTTPS in the Windows Server port 443 and had a 5.0 score. As you can see below, certain common CVEs, otherwise known as common vulnerabilities and exposures, are displayed below. So these vulnerabilities were already discussed between common IT teams, and thus, because they have been tackled before, we have solutions available. So what we can do is that we can access the register keys in the Windows Server located in the file that I display below, and what you can do is disable SSL 1.0 and 2.0 and enable SSL version 3.0, otherwise known as Transport Layer Security version 3.0. Next, there are certain cipher suites that are regarded as anonymous, meaning that they don't have an identification and that they can be accepted by a service. This was found for the protocols SMTP and the PostgreSQL in the Linux Ubuntu server. What makes this such a dangerous aspect is that it can allow remote attackers easier access to obtain the sensitive information and thus make any other unspecified impacts. It's another medium level criticality vulnerability, and it's mostly prevalent in the port 465, otherwise known as the port exclusive to the SMTP protocol. The CVEs have already been displayed, and the latest one is 2014, so we can already guess that this vulnerability has been addressed quite a while ago, and we can have certain instructions on how to remediate it. In fact, I will display them below. Is that we can tweak the OpenSSL protocol by using the Linux command that I included here. We have to go to the Apache 2 page, type in the command below. What happens is that the following strings in the Linux command include so many anonymous ciphers, and to ensure that none of these ciphers are permitted, that's why the purpose of using this particular Linux command. OpenSSL ciphers -v all colon, exclamation point, A null, exclamation point. Ensure that none of these ciphers are permitted when configuring it, and you can remediate this and this is technically not considered, it can be considered a vulnerability, but because it's not super prevalent, except from the findings, we have to address this, and we can consider this a high criticality finding. What happened was I discovered that the DNS protocol, the domain name system protocol, couldn't be found during the scan. And that's an issue because if you want to use the Windows service, you have to be able to access web services in order to access web pages. And you can't do that without the DNS protocol because it forms the backbone of the web services as the phone book of the internet. It's what translates the URLs that we input into IP addresses that serve as the locations for which servers can access information, access web pages. I found this in the Windows server, and the remediation is obvious. You have to install it, you have to enable it, and you have to configure it if it hasn't been done. And I already discussed these steps in previous presentations, so I'm just going to go through them very quickly. You go to the server manager, add the roles and features, select the DNS server and add the features, confirm them, install them, and wait for the installation. Another thing that I would highly recommend is that you ensure that you open a port that's common for DNS on Windows. I suggest further research, and it's imperative that that port be allowed access in the scans. So in conclusion, even though I label this final finding high, it's not technically counted as a vulnerability from the scan report. So I'm not entirely sure where to go from here, but rather just to enable DNS as a solution. But it looked very well configured, very well hardened, and it was very impressive. So I would suggest that this work be considered quite good quality. Mistakes were made, but that's the matter of being human. We cannot completely secure everything. That's not a possibility. Information security is a process, not a goal. Because if we did completely secure everything, no access would be enabled. We take a risk the second we access something on the internet. And these are all the reasons presented, and that's the end of my presentation. Thank you very much for taking the time. I'm Kevin Lopez Castellanos, and I wish you all a good holiday break. Thank you for a great semester. Bye.